Section 5.5, Inequalities in a Triangle. By the end of this lesson, you should be able to use triangle measurements to decide which side is longest or which angle is largest, as well as use the triangle inequality theorem. To get us started, let's take a look at the situation. We have triangle ABC with the different angle measurements shown. And we want to be able to answer which is the shortest side and which is the longest side of this triangle. We can usually tell which one's going to be the smallest angle or the largest angle, but as far as sides are concerned, we really don't have measurements to go off of to determine this. What we can do is we can explore this to figure out the answer. Moving this over so you can see it a little bit better, I've made a triangle here in Sketchpad. And if we show the angle measurements here, we can see the measurement of angle A is 32 degrees, the measurement of angle B is 99, and the measurement of angle C is 50 degrees. Let's see how this matches up with our measurements of our side lengths. And our side measurements here are 8, AB is 8 centimeters long, and BC is 5 centimeters long, and CA is 10 centimeters long. Now there's a relationship between the side lengths and the angle measures in a triangle. Are you able to figure out what that relationship is by looking at this diagram? Well, let's take a look and find out which one is our smallest angle measure. Our smallest angle measure is here, and it is 32 degrees. Let's take a look and see which one our shortest side length is. And we have 5, 8, and 10, so 5 is our shortest side length. Our largest side length is 10 centimeters long, and our largest angle measure is 99 degrees. Taking a look at the placement of these, we start to notice a pattern. If we take a look at the medium angle measure and the medium side length, we notice that they are here and here. So looking at this, I'm noticing the pattern that this smallest angle measure is going to be across from my smallest or shortest side. The largest angle measure is across from the largest side, and the medium-sized angle is going to be across from the medium-sized side. Which brings us to the following theorems. We can say that if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So looking at the triangle in this diagram, we can see that side AB is shorter than side BC. And we can also say that side BC is longer than side AB. Now, the angle that's across from side BC is angle A. And the angle that's across from side AB, let's choose a different color pen here, is angle C. So looking at this, we are able to say that the angle measurement of A will be greater than the measurement of angle C because of this theorem. We have another theorem that has to do more like the problem that we started with, and that says that if one angle of a triangle is larger than another angle, then the side opposite the larger side is longer than the side opposite the smaller side. Well, let's take our pens again and take a look at this. So I have this larger angle that's 60 degrees, and that's across from side EF. And we also have this angle measurement here, we will call it the smaller angle, that's 40 degrees, and that's across from side DF. So if we wanted to compare the measure of the two sides, we can say that the larger side or longer side is going to be side EF, and the shorter side is going to be DF. So we can say that EF is greater than DF based off of these two theorems. Let's return to the initial problem that we had started with. and that was which is the shortest side, which is the longest side. Well, looking at our triangle, I can start to order these angle measurements. I'm going to call this my smallest angle measurement. I'm going to call this my medium-sized angle measurement, and I'm going to call this one, the 120-degree angle, my largest angle measurement. The next thing we're going to need to do is take a look at what sides these are across from. So my smallest angle measurement is across from side AB. So we can say which one is the shortest side. Well, segment AB is going to be our shortest side. Similarly, we can take a look at our largest angle, and we can see that 120 degrees is our largest, and that is across from BC. So our longest side will be side BC. Now that we've taken a look at the relationships between the angle measures and sides in a triangle, let's talk about the triangle inequality theorem. And to get us started with that, we will take a look at a short little video. All right. So we're investigating if we can end up making a triangle out of 3 segments. One that is 1 inch long, one that's 3 inches long, and one that's 2 inches long. And if I play around with this, trying to just match these up, I'm going to find out that I'm not able to do this. Because even if I try rotating this over as much as possible, I won't be able to get the 1 inch segment and the 2 inch segment to ever intersect. And the reason for this is because the 1 inch segment plus the 2 inch segment is going to equal the 3 inch segment. So by the time they're able to all touch one another, they're not making a triangle. They're just making a line segment, and that's about it. This brings us to our theorem. And our triangle inequality theorem states that the sum of the lengths of any 2 sides of a triangle must always be greater than the length of the third side. And we saw in the last video that when they were equal to, you were not able to make a triangle, and if they're less than the third side, you're not going to be able to make a triangle either. So as we take a look at any triangle, we're going to need to see some things. My side lengths here are AB, BC, and AC. So any of the 2 side lengths, so when we go ahead and take AB plus BC, that will have to be greater than AC. We will also need to see that if I take side BC and add side AC to it, it will have to be greater than side AB alone. And lastly, we'll have to go ahead and take side AC with AB, and those added together will have to have a sum that's greater than side BC. If this is true for all 3 inequalities, then we know we're dealing with a triangle. If it's not true, then it's not a triangle, because the triangle inequality theorem states that any 2 sides, the sum of any 2 sides, must always be greater than the third side. And let's take a look at an example problem. Is it possible to construct a triangle with side lengths of 13, 14, and 27 meters? Why or why not? Well, we're going to need to take a look at our 3 inequalities. I'm going to need to see that 13 plus 14 is greater than 27. I'm going to need to be able to see that 14 plus 27 is greater than 13. And lastly, we'll need to see that 27 plus 13 is greater than 14. And looking at this, you might start to notice a couple patterns, I guess you can say, with it. That if I have 27 on the left-hand side that I'm adding, I already know that 27 is greater than 13. So anything I add to 27 should be greater than 13 as well. So we can say that yes, the second one works here. 27 plus 13, similarly, is going to have to be greater than 14 because 27 on its own is greater than 14. So we can say this one works as well. Now, when we take a look at the first one, if we take 13 and add it to 14, my sum is 27. And this question is stating, is 27 greater than 27? Is this inequality true? Well, it's not true, because 27 is equal to 27 and not greater than. So our answer to this, are we able to construct a triangle with side lengths of 13, 14, and 27? We would say no. And then it does not satisfy the triangle inequality theorem. We've wrapped up the rest of this lesson, so it's time for our joke. Our joke today is, if you live in an igloo, what's the worst thing about global warming? Well, if you live in an igloo, the worst thing about global warming is no privacy.